Today we'll be doing the integral from 0 to infinity of e to the minus x times the cosine of x dx. And we could recall an identity that the real part of e to the ix is equal to the cosine of x. And implementing that, we have this is equal to the real part of the integral from 0 to infinity of e to the minus x times e to the ix dx, and now we could combine those exponents. This is equal to the real part of the integral from 0 to infinity of e to the minus x plus ix dx, which is equal to the real part of the integral from 0 to infinity of e to the minus x times 1 minus I dx. I just factored it, and now we solve this integral. So it's equal to the real part of 1 over negative 1 minus I times e to the negative x times 1 minus I, validate at x equals 0 to x approaches infinity. So this is equal to negative the real part of 1 over 1 minus I times e to the minus x times 1 minus I from 0 to infinity. And now we could multiply by the complex conjugate. And now we have minus the real part of 1 minus I times 1 plus I over 1 plus I times e to the minus x times 1 minus I from 0 to infinity, which is equal to minus the real part of 1 plus I times 1 times 1 is 1. We have I times I, but negative, so minus I squared e to the minus x times 1 minus I from 0 to infinity. And we know that I squared is minus 1, but the negatives cancel to a positive 1, which becomes a 2. So it's equal to minus the real part of 1 plus I over 2 e to the minus x times 1 minus I from 0 to infinity. We could bring down the 1/2, and we have negative 1/2, the real part of 1 plus I e to the minus x times 1 minus I, where x equals 0 and x approaches infinity, is equal to negative 1/2, the real part of 1 plus I times the limit as x approaches infinity of e to the minus x times 1 minus I minus e to the 0. So it's equal to negative 1/2, the real part of 1 plus I times, as x approaches infinity, this limit tends towards 0, and e to the 0 is 1, but negative. So it's equal to negative 1/2, the real part of 1 plus I times negative 1. And we have negative 1/2 times negative 1 times the real part of 1 plus I. I just factor out the negative, and a negative times a negative will make a positive. So we have 1/2 the real part of 1 plus I. And the real part of this complex number is just 1. So we have 1/2 times 1, or 1/2. So now we have that the integral from 0 to infinity of e to the minus x times the cosine of x dx just equals 1/2. And this is the final result. Thank you very much for watching.